do this. So what I wanted to do now is I want to introduce you in what is the things that you have to do in order to write tests for PHP. So the first thing you have to do is you need to have the PHP source code, because with the PHP binaries that you install on your systems, usually the tests are not shipped with, and the test runner also not. So what you can do is you can just clone the source code from the GitHub repository. I would advise you to create a fork before you clone it, because I would assume, including me, that nobody here has push rights on the PHP repository in GitHub. But the source code itself is all there. You can just fork it and then clone your fork. And what you have to run is, in order to compile the PHP binary from source, is you have to run the build.conf script that creates the configure script, then run the configure script. Then you call the make. Make basically calls the compiler and compiles everything, and then in the end links together the binary. That's nothing too fancy. You just need to remember that you have to do this, and after that you have your binary. And just for the sake of it, and to prove that it's actually working, we are going through this now. So you should see my command line. And I have a checkout of my fork of the PHP source repository here. And all we're going to do is run build.conf. Build.conf creates the configure script. Then we can run the configure script. And in my case, because we're going to need that later, I need to add the with setlib argument. What configure does is configure runs through and checks if all the dependency, the libraries, the header files, just everything the make later then needs in order to actually compile the source code is installed on your system. It might be that the configure script fails on you with a warning that I had, for example. The warning that I had when I wanted to run this the first time was that the configure script was complaining that I do not have the libxml installed. So actually, the libxml is installed. What it's missing is the header files. So what you usually need to install is you need to install then the libxml development packages, which is usually called something like libxml-dev or libxml-devel on your system. And if you install that, then configure will not complain anymore. It might be that it complains on other libraries that are missing, but it's usually the same. Just install the development packages and everything is okay. So after we have the configure script running, and seems like configure is happy with the system. It looks like everything is there. We can just run make. I actually prepared all of that already because it takes some time to compile the source code. So what's actually happening right now is the compiler's not doing anything anymore. All the object files are already there. This is just the linker doing its work, linking together the object files to a binary. This might take a few seconds. In the end, when everything is done, and the linker has linked together the binary for us, then we can actually call that one and check what we got. So it should be the latest PHP 8 or 8.1, because I compiled it from master today. And you might also see when I prepared this talk. So the linker is ready. The binary is placed in SAP CLI PHP. And when we call that binary, we see that it's actually PHP 8.1 already. And you can also see when I prepared the talk, or when I compiled that one, it's exactly now 29 today. So that's as fresh as it can be. I would not advise you to use this to host your production system. We'll see later, because there are some failing tests. Okay. Now we cloned the repository, we configured it, we compiled the binary, we have it running. So there is a PHP interpreter that actually works. So now how to run the tests. There is a test runner, and we can use the make command to run the tests. So we're just gonna copy and paste that one, paste it into the command line and run it. And what actually happens now is, since PHP 7.4, the test runner can run with concurrent test workers. Before that, there was just one test executed after the other. Now you can run them in parallel, which makes it way faster. Basically, on the left side, we see a lot of passes. There are some skips we don't see because they're scrolling by so fast. Then there are some I guess, one warning and one failure. We see that in the test results after that. In the end, there are some tests that cannot run in parallel. So you can mark your tests that they should not run in parallel, and then the test runner will execute them at the end, one after the other. So let's scroll up. What we have here is, let's zoom in a bit more. Okay, what we have here is we have a test result summary. Actually, we have, you see that we have 16,598 tests in the PHP source code, and 11,558 of those tests have been executed. You see that we executed all those tests in roughly 35 seconds, which is pretty fast. And we have 5,000 tests that are skipped, one warning, one failure, and 28 expected failures. If you scroll a bit down, you see the expected fail test summary. This is a list of all the expected failure tests that have been executed and that's like still exist. An expected failure is something like you write a test for something, and you know already that there is an upstream bug in an upstream library, whatever that is, and they have to fix that bug, but you already have the working test in the PHP source code. So for this point in time, you can mark it as expected failure. And what happens when the upstream bug is fixed is that your expected failure will be in the warn test section, because suddenly it passes. Oh no, where is it? Oh yeah, that one. In the warning section, because here is, you see there is one test in that file that has an X-fail section, but the test passes. This should not happen, but this means that more likely the upstream bug has been resolved, and now the test should not fail anymore. And then there is one actual test failing. I don't know, someone has to have a look into this one. And that's basically it. So now we have run the tests. I want to show you in the next slide how those tests actually looks. So this is the test file format. It's a PHP extension for PHP test, and it consists of some sections. So first of all, we have the test section. The test section is nothing too tricky. It's just a simple description of what you're going to test. And this is also what you can read in the command line when you execute the test. If you want to write more text, you can actually use a description section for that and write more descriptive text of what's going on here. The test section is mandatory. You need to have that one. Then the next section, I also added to this minimum example. The skip if section is optional. You don't need to have that, but you're going to see that in a lot of test files, because as we already learned with the zip extension that we're going to need later, some of these extensions that you have in PHP are not bundled by default. Like, for example, the zip extension is not bundled by default. You need to explicitly compile that one. So it makes no sense to execute a test if that library you are depending on, the extension you're depending on, is not even installed. So you can use the skip if section. The skip if section works basically as following. The PHP test runner will execute the PHP source code in the skip if section, and if the output starts with skip, it will skip the test. That's basically it. Then one of the next section that's mandatory is the file section. The file section is your actual test. So what's going to happen here is that the PHP test runner will run that section of the code, and will then match the output that the PHP binary then created running that snippet, match that output against the content of the expect section. So in this case, what we're doing is we are just we're calling string lang with a string. We are calling var_dump on the return value, and we are expecting that it returns outputs int 12. That's what the expected value is. What the PHP test runner will do, it will match against the expect section. If it matches exactly, then the test passes. If it doesn't match, then the test fails. In some cases, you might need to use substitution tags in your expect section. So in this case, it wouldn't make no sense, but you could replace the 12 with a %d, and that would actually also match. It would render the test completely useless, but it would technically work, and it would have a passing test. Where you need the substitution tags from printf is something when you, for example, test an exception, or you get a stack trace or a back trace from an exception. Then the path that you see in the stack trace depends on the system where it's running, so you can just replace that with a %s sign. And then it doesn't matter where the file actually is in the file system. So you can make the test independent from the environment where it's run. Then there is a last section, the clean section. The clean section is optional, but the basic purpose of the clean section is that you clean up after yourself. It might be that if you trigger a bug, that the PHP process will die in the file section, or it will return or die or throw a fatal or whatever. Something might happen that you have files laying around after your test has broken. Then you can add a clean section. The clean section will be called after every test run. And the idea is that you can clean after yourself. One thing you need to know about these 3 sections that we have here is that all these sections are executed in isolation, meaning that for the skipper section, there will be a file created on disk, and then PHP will be called with the contents of just that file, which is the contents of the skipper section. And after that, a new process will be started to just run the part that we have in the file section. And for the cleanup, it's the same. So what you cannot do is, or what I stumbled upon is that in the test section, I created a file, stored the path to that file in a variable, and then in the clean section, I wanted to unlink that file from the variable, but the variable doesn't exist anymore. So you need other ways around this. Okay, now that we know how a test basically looks, or how it can look, what should we test? So when I started writing tests in PHP 7.1 times, there was gcuff.php.net. That's still there, but it's outdated. So it doesn't have the code coverage report for PHP 7.4 and up anymore. So what you can do is you can head over to Azure Pipelines. And if you're interested in this, just ask me and write in chat, then I can show you after the talk how this looks. Find the latest scheduled build. And for every scheduled build, there is a code coverage report generated, and you can find that one in the Azure pipeline. And then you can go through the source code and find something that's not tested. And when I went through the source code to find something that wasn't tested, I found that. So let us go through this. What is this? This is the setlib get coding type PHP function. And this is a screenshot from the old gcuff.php.net page, not from the new Azure pipelines, because there is it's green already. Okay, when I found this one, you see in the first, it's red. It has zeros in front of the lines. So there is not a single test testing this setlib get coding type PHP function. So we need to find out what this function actually does. So what you can do is you can go more through the C code, what it actually does. And what we see here, it looks not too complicated. There is this send pass parameters none and an if block that does something. Who knows what it does? And it returns. And after that, there is a switch statement. And it seems to switch over a variable called compression coding. And this compression coding variable can have 2 values. It looks like something, a constant, PHP setlib encoding gzip or deflate. And then it returns a string gzip or deflate to the caller in user space. Or if it's something else, then it returns false. At least it looks like this. So what you can do is you can bake that up by going through the documentation on php.net/setlib get coding type. You can read about what this function actually does, and you basically read exactly this. And you also can find out about the bigger context of the function. So the bigger context of the setlib get coding type function is the following. When you send an HTTP request to a server, your browser might send an HTTP accept encoding header. And in this accept encoding header, your browser can communicate to the server that it actually understands a gzip compressed response or a deflate compressed response or just a plain text response. And what PHP can, on the other hand, PHP on the other hand has an ini setting that's called output compression. And if you enable the output compression ini setting in PHP, and the client with the HTTP request signals the server that it actually understands gzip or deflate, then PHP will magically do output compression. And you don't have to do anything in that. The only thing you have to do is you have to turn this switch on, and PHP will magically do this for you. So when we know this, we can check out what tests we got to write. So we need different tests. We need a test for the absence of the accept encoding header. In that case, the setlib get coding type function should return false. If the accept encoding HTTP header is set to gzip, then we expect it to return gzip, or when it's set to deflate, we expect it to turn deflate. Or when the accept encoding header is anything else, not gzip, not deflate, because we see it in the source code, anything else is not supported, it should return false. And we also need to check the value of the setlib output compression in the setting. When that's off, then whatever is in the accept encoding header, the setlib get coding type function should return false. So, and I would say that we are going to write this test. I prepared a little demo. So the first one of the tests is already there. So this is the test I wrote for the setlib get coding type with gzip encoding. We already learned that I had to actually use this with setlib argument in the configure step to actually compile the setlib extension into the PHP binary. So this is an optional extension. It's not usually here. So we need a skip if block to guard in case the setlib extension is not installed. In this case, just an if not extension loaded setlib, then print skip. That's basically it. And if the setlib extension is not here, or not installed or activated, then the test runner would just skip that test. Now to the interesting stuff, the file section. So what we have here is we heard that we need to have access to this accept encoding HTTP header. And as PHP developer, we know that we can grab all the HTTP headers that the client has sent to us via the $_server superglobal. So in this case, if the client would send an HTTP accept encoding header to us, we can just read it from $_server HTTP accept encoding. In this case, we want to modify that value, so we set it to gzip. Then we set the setlib output compression variable to off, which means that PHP should not do output compression for us, no matter what the client stated, that it understand. Then we can call the setlib get coding type function that we are testing, and we are just giving the return value to var dump. Then we can set the output compression to on again, or whatever it was before. We set it explicitly to on, then var dump it out, and we would expect that when the output compression is set to on, and the client indicated that they accept an gzip response encoding, we would expect this var dump to our string for gzip. So the first one should return bool false, and the second one should return a string of 4 bytes gzip. And we can actually just run this test and see how it works out. So if you want to run specific tests, you can give it just call make test and give it a tests variable and specify where the test is. In this case, it's that one. So when we run this test, we get a lot of information about our environment, so about the PHPS API, the PHP version, the send version, the PHP OS that's running, Linux kernel installed, and so on and so on. And we also get information that our test failed. That's bad, but at least, as you can see, it failed in 0 seconds, so that's the good thing, the only good thing about this. I told you in the description of the PHP file format that there is a lot of sections, and what actually happens is that the test runner will split those sections in specific files, run those files, and log the output. And what we can do is, we know that it was one.phpt, which was our test file. Oh, wrong file, phpt. That's the test file. And when we now tab here, we see that the test runner created a lot of files, and it left the files untouched because the test failed. So there is a one.div, one.x, block out, PHP, and all these stuff. What's the interesting file is the one.log. In the one.log file, we see the expected output and the actual output and the information that it failed. And what we see is that the first expectation is actually matched. We expected a Boolean false, and we got that one. But after that, first of all, we got a warning that by the call to the any set that we cannot change setlib output compression because headers have already been sent. And then we got a bool false, where we expected a string. So I would say we open the file again and try to tackle this warning, because when we cannot change the setlib output compression, it's no wonder that the next line is Boolean false, because like we tried to change the value, but it actually did not change. So let's have a look at the test file. And when we look at this, then I guess most of you already see what the problem here is. We call initSet, and that set the output conversion to off. Then we do the var dump, which actually does output and sends output to the client. And that's the problem here. We are sending the output to the client, and the accept encoding header in the HTTP request from the client is only a half of the part. The other half of the part is that the server in an HTTP response header has to tell the client what kind of encoding it actually used, because the client can not only state that it accepts an encoding of gzip, it can also say, I accept gzip and deflate, but I prefer deflate. And then the server is still free to decide to use gzip anyway, because the clients say that they also accept gzip encoding. So we need the server needs to tell the client what encoding it actually used then, or if it just didn't use any encoding, if it's just plain what comes through the wire. So the problem here is that when we do this var dump in this place, and the PHP interpreter writes this bool false to the wire and sends it to the client, what happens magically without us doing anything is that the PHP interpreter will also send out the HTTP response headers to the client. And in this case, it tells the client that the server is not doing any kind of encoding. And now we cannot change this anymore, because there is technically no way to send just a bunch of bytes in plain, and then in the middle of this stream just communicate to the client that, oh, I just changed my mind. Now I'm doing output compression for you. And it's gzip, by the way, good luck. The client will not be able to do anything with this mess. So we're not able to change the ini setting. But what we can do is, just for the sake of the example, we can just store the return value of these calls and var dump that out later. So like this, we call the setlib encoding type, store the information in A, then call initSet again. Now we did not have done it. There was no output. At least there should not be any output. Then we call setlib encoding type again and have $A, $B, and then we var dump that out, and that should actually work. So let's see if we actually got it working. We can run the test again, which just make test equals foo/1.phpt. And when we run that, it still fails. But we already know we can have a look at the log file and see what it has for us. And this is tricky. The first expectation is still true, but the second is interesting because we do not have a warning anymore. It seems like there is no problem, but it's not working. It's not working as it should work. So the question is, what's going on? Now what you can do is when you stumble on these kind of problems where you just can't wrap your head around what's going on. We are writing to the accept encoding $_server superglobal. There's gzip in there. It should actually work. What you can do is you have two options now. One of the options is you can go to the source code and have a look what's actually happening. And we are going to do that. And just zoom in a bit more. And this is the source code of the setlibc file, where we also find the setlib encoding type function. And I searched on the compression coding variable because that is the variable that we are actually switching on. So I searched for the compression coding variable, and these two lines are the only two lines where there is something written to that variable. And when you read through that, you see there is a lot of macros in the source code, the set type and PG and whatever that does. Actually, I have no idea. But in the end, if you go through this, you see that there seems to be an access to a server super global variable. You see this PG HTTP globals track var server, whatever that is. Looks like it's checking if that is an array and if it's an auto global. And then it has does a read access to that server, $_server var, and it checks for something HTTP accept encoding. And that looks familiar because we wrote to that $_server HTTP accept encoding variable. So it gotta be there probably, but it looks like it's not. And then there is a convert to string function being called with whatever we found there. And if that is gzip, then the compression coding variable will be set to that value and to that value. And those are the two values we found in the switch again. So it all sums up nicely, but somehow it's not working. So in the end, I didn't know what to do. So I went to the phpc.chat. In the phpc.chat, you can find a lot of people from the PHP community. And I then asked the question to those people, what's actually going on? I just don't know what's going on. And what they told me, the problem is not with the source code itself. The problem is that what I forgot is that PHP is a copy on write language, and copy on write will happen in any user space thing in PHP, but copy on write also happens for the autoglobals, for the user generated autoglobals that exist. So $_server, $_get, $_env, whatever you have are all superglobals that PHP creates for you. But also all of those superglobals are copy on write, meaning, let's go back to our test, meaning at this point in time, when we in the user space write to $_server HTTP accept encoding, what will actually happen is that PHP creates a copy from us in user space to work on. And the PHP core itself will still work on the unaltered original, which effectively makes the HTTP request immutable to the PHP core. So from the user space, we cannot change how the PHP core reacts with or interacts with the original HTTP request, no matter what we do. And when you think about it, actually makes sense, because when the HTTP, when the client sends that they accept no encoding at all, and we in the PHP script decide, oh yes, they are going to accept gzip, and PHP would send out a gzip compressed output stream, then there's going to be a problem. The client will not be able to understand what we just sent to them. So it looks like a dead end to here, but luckily there is a lot of other sections in those PHP files. And there is one section that's the env section. And what we can do with the env section is we can inject environment variables into the process. So that's exactly what I'm going to do. We are just injecting the HTTP accept encoding environment variable into the PHP process when it starts up. So the test runner will set this environment variable for us and then call our file. So that would mean that we are not in the user space changing the $_server superglobal anymore. And the accept encoding header should already be injected into the process. And it should look like for PHP as if there was an actual HTTP request with an accept encoding header being set to gzip. Let's cross our fingers and try that. And when we run the test, we see that it fails again. But we already know now, we can just have a look into the log file. And the log file is pretty interesting in this case because it gives us some binary gibberish that, like, I don't understand whatever that is. We can try to open that with Vim, and we see that there is also some, I'd say, a lot of non-printable characters, a lot of stuff going on here. But wait a minute, that could actually be something. That could actually be the following. Let's just go through the test. What have we done? We have a client that indicate that they are accepting gzip encoding. And at the very end, we turn the output compression on. So that could actually mean that PHP is actually doing what we intended it to do. It is doing output compression because it's allowed to do. The output compression in setting is turned on, the accept encoding header is there. So it might be that what we saw there is just a gzip compressed output stream. So for the simple example, let's just turn the output compression off again. And when we turn it off, it should actually run. We'll see. And as you can see, the test passes. And now nobody's asking us anymore if we want to send a feedback because we have a running test. So actually that solved the problem. We have now the final running test. So let's get back to the presentation. So to sum it up, this is the test file as it is in the PHP source repository. At least I guess. It should be pretty near to that. We have our test section, and we just state what we are going to test. We are testing the setlib coding type with gzip encoding. We have our skip section. We have the environment section. And then we turn the setlib output compression off, then call the test function under test, then turn it on again, and so on and so on, do the var dumps, and we expect a Boolean false and a string gzip. Then we're going to do the exact same for deflate output compression, and for a HTTP accept encoding being set to something just a string that's not gzip or deflate, and then without any HTTP accept encoding. So when I committed that pull request to the PHP source code, and after it got accepted for PHP 7.3 in the old gcuf.php.net code coverage report, you can find now this. The function is actually tested. We have 4 test files. So it's 2 calls to setlib coding type per test. So it's 8 calls overall. And you see that we now have 100% coverage of not 100% coverage, but the send parse parameters non-function is something that you do not need to test explicitly because it's tested elsewhere already. Basically, just an excursus, what this does is if you call setlib coding type with arguments, but the function doesn't have any arguments, then you get a failure because you shouldn't call that. Okay, what did I learn from this entire thing that I did there? First of all, what looks simple might be complex. The usual thing. So to be honest with you, I stumbled on this, and I was super happy that I could find a function that's so small. I mean, you could break it down to this is just a switch on a variable, and it has 3 different return values. That's it. That's not too much, right? But in the end, it was a long journey, and I learned a lot. For example, I learned that superglobals are copy on write too. It's not just with the variables that you do in user space and pass on to your functions, and as long as you do not write on them, you're actually working on the reference. And PHP takes care of creating a copy for you if you start writing. Superglobals are basically the same. That's interesting. And the next is that I learned that there are modify handlers for any settings. If you are interested in seeing that, just ping me after the talk and I can show you how these modify handlers look. So basically what happens is when you call any set and just set an any setting to a value, it's not just toggling a Boolean flag or setting something. It actually might call a function that checks if what you are trying to do is actually allowed. So what brought that on my table is that I now, when I call any set, when I have to call any set in my source code, I actually check on the return value because it might be that it did not change the any setting that I wanted to change. Then you might ask, what do you gain? Like when you start writing tests for PHP, first of all, I guess one of the good things, PHP will be more stable and more reliable. It will not be that in the next release, there will just out of a sudden change in behavior in that function because you nailed down the behavior of that function in that test. That's a good thing. The next thing is what you gain is you gain a deeper understanding of how PHP works internally. And in most cases, it's a good thing to know how the layers below you actually work because PHP allows us to do a lot of crazy stuff that will never ever map onto what the CPU actually has to do. And just for the easy layer that you can write on, PHP does a lot of work that this actually works what we are doing. And if you know more about how PHP works internally, you can actually help PHP run your software faster. And an interesting thing is, when I was on the lookout for something else to write a test on, I found out that there is a zip archive class in the PHP core. I didn't even know that this thing existed. And the last time before that I had to work with zip files in PHP was roughly 10 years ago. And back then I wrote a class that basically wraps system calls through to the zip and unzip binaries. which was a horrible, horrible thing to do. And I would advise everyone to not do this. Just use the zip archive class that I learned that actually exists, and I wrote some tests for it. And a few weeks later, the funniest thing is, a few weeks later, I actually had to open a zip file and extract some files from the zip file. And I knew then that I could use the zip archive class, and I didn't have to call the zip and the unzip binary on the computer, on the system. And the next thing is that the PHP test format, it looks like it's nailed down to just tests for PHP. But actually, PHP Unit has a test runner that can execute those PHP test files. And a lot of stuff in PHP Unit itself is tested with PHP files. And that actually is how I became a PHP Unit contributor. And in the end, if you start writing tests for PHP, if you make your pull request and if it gets accepted and your code is in the PHP source repository, you can tell everyone, if they want to hear it or not, that you are a PHP Core contributor. Thank you very much. That's all I have for today. And if you want to go deeper into that rabbit hole, you can head over to phptestfest.org. It's a bit outdated, but it's still all true, the documentation. Then there is qa.php.net, where you find the quality assurance page of PHP and also the description of the PHP file format. And there is a lot of other sections to explore. And then there is dotbox.org, which is my blog. And there you can also find a blog post on that topic, on how to compile, how to write tests. And there is even a extended version with how to generate your own code coverage report. Thank you very, very much. Any questions?
Yeah, so Danny here. Thank you for showing us. It's actually much easier than I would expect it.
That's good to hear.
I'm always fan of testing. I'm actually curious, where would you, because you mentioned it, that there's a Azure pipeline that's having that coverage report and would actually be, I guess, the place to get started on finding something that's not covered. So I was curious where that would live.
Yeah, I'm currently trying to head there, but for some reason, let me just check. Maybe it's that looks better. So the link is where do I have that link from? I guess you can find the link on the GitHub repository itself. In the here you can find it. That should be, yeah, that's Azure pipeline. So here you can look for the different pipelines that are running, and here you can find one of the Azure pipelines. Here you find the link to the run itself. In the end, you are landing on that page. And sadly, that's a bit tricky. There's no single place where you have the code coverage report now. It's not deployed to somewhere. But what you have to do is you have to look for scheduled build. Oh no, there's no scheduled build. Damn. There are some scheduled builds, usually for the master branch. So let's check out the master branch. Here we have it scheduled. If you see something like that, these here go the scheduled build for master branch. Oh, and that failed. Then you can go into that, and here you have the summary, the tests, and the code coverage. And here in the code coverage report, you see the summary. So you see it's 75% line coverage. And then you see some bars here, and then you can go down, and we can go to the setlib.c. That's where I wrote the test for. And here we can go to the setlib get coding type. That's the function. And now you see there's a lot more tests since I last worked on this. So here you can find it. And if you read the blog post that I wrote, then you can create your own coverage report locally. It takes a while to create the code coverage report, but it's worth to check if you're actually covering the lines before submitting the pull request.
Okay, cool. Thanks for that.
Any additional questions? If not currently, then I can show you something else. So I mentioned that there is a when you do an ini setting, when you call ini set, then what actually happens is there is functions being called. So this is the setlibc file. And what we have here is any extension that has that brings its own ini settings with has a PHP ini begin and PHP ini end block. And in this block, you have these macros and give it some values. And what you give it, for example, is the name of the ini setting. So in this case, what we are working on is the setlib output compression. The default value of it, I don't know what that is, and then a function pointer that points to a function that's being executed when that value is being changed. And when we search for this function, we find it at the very beginning of the file, or is it the beginning? Oh, okay, no, it's not the beginning, but we find a C function here. And what is interesting here is the following. We see the error that we got earlier. Cannot change setlib output compression headers already sent. So what happens is we call iniset with the setlib output compression and set it to on to off, whatever we do. And what happens is then that the PHP runtime would actually call this function, run through it. It will do some kind of checks, and what it will do, for example, is it checks if the PHP ini stage runtime, whatever that is, I don't know. But what it does is there is a PHP output get status that gives you a bitmap back. That's basically an integer with some bits set. And then you can bit end this whatever you got against some constants. And one of those constants is PHP output sent, which basically means that PHP will tell the extension that output has already been sent. And that means that in the case of the setlib output compression variable, that we cannot change it anymore. So it's not only that we can change it from off to on, but also the other way around will not work anymore. It's the same with when you set a session cookie, for example. You cannot send out some headers anymore when the output has already been sent. So here's that one. See in the chat, is there a special format you use when creating a pull request with just test? No, there's nothing special. You need to keep it. You need to make your fork to make a pull request, but other than that, there is no special format in the pull request or what you have to write. Just make your pull request and state that you found out that there is no test covering that single line or that function, or there is no test that covers this case, and you actually added a test. And just make sure that you run the test up front and you create your own code coverage report to actually make sure that you cover that line, because people will actually go through that, and it's just polite to do this up front. That's the only thing. In the end, I got this question asked last time I made this talk, how long it takes for a pull request to be accepted if it's just tests. And no added feature, no other stuff changed in the C code itself, but just an added test. It might go as quickly as just 30 minutes. So let's just skip the writing test. But if you write a test and just skip that, you can be a core contributor in 30 minutes. Sometimes, not always. The naming convention for the tests and where do you put them? So let's just go through this. So usually what you have is there is a test directory which tests the basic language stuff. So everything that's in the, let's say, core extension. But usually the tests are in the extension itself. So we have an X directory with all the extensions. And in this case, I have the setlib file. So the setlib extension was the extension where I wrote tests, and there in all these extensions, you usually find a tests folder. And that tests folder is full with tests. Actually, I do not 100% know that there is the schema, but let's just call it, there is usually it's the function name and then something like basic, which means just the let's say, basic functionality if something exists, but that's that. The test that I wrote for the setlib coding type should also be here somewhere. Here we have them. There is a setlib coding type basic, BR, deflate, and gzip. Let's have a look into BR. So this is the setlib coding type with unsupported encoding. BR is one of the encoding. I don't know what it's actually pronounced, but BR is one of the encoding that Chromium-based engines support. And I have the skipf block, so if the extension is not loaded and so on and so on. And the HTTP accept encoding is set to BR, something that's not expected or not supported, and then we expect true false. So I would say from a naming convention, just name it as the function you're actually testing. So in my case, this was setlib coding type is the function, and then the variations. So the variations I have is the basic is a stupid naming, but it's there. I found that there's this gzip open basic and basic 2. I don't know what basic 2 is. Basic_1. Okay, and you should just do the variations that you have. So in this case, it's basic, BR, deflate, or gzip. And then there is other things like when there is a bug, then it's just bug and the number of the bug. So we can have a look into what that actually is. So it's bug whatever, inflate needs the terminating null byte. And then there is a test for this. That's that. Any other questions? If you have questions after the talk or later or tomorrow, hopefully you all start to writing tests right now. If you have questions upcoming lately, just ping me on Twitter or head over to phpc.chat. There is usually Sarah Goldman and Benny Ramsey and Derek Retans, and they are always very happy to help. They're very supportive people. And maybe you've seen that few weeks from today, there was a blog post from Joe Watkins posting about the bus factor on PHP and the PHP project. That it's only, I guess, 2. So basically, there's 2 people on the entire planet that do the main part of the PHP project. The way for testing of PHP 8, nothing changed. That's the source code that I have here is the PHP 8.1. It's the master branch, so it's the current develop edition of the PHP 8.1. So this is the master branch, and this is what will head to the PHP 8.1 release. So all the nice new features that have already been merged into PHP 8.1 can be tested in the master branch, and there is nothing different. The only thing that changed in the testing was with PHP 7.4, I think, when they started to add a test runner that was able to execute tests in parallel. Before that, tests were executed one by one. But there is, if that answers the question. Great. Then for the time being, thank you very much.
Do they have all the contact information?
My contact information?
Yes, your Twitter account and other.
Yes, it's posted in Meetup.
You made the post on